here, and today we're going to learn how to prove that a recurring decimal can be expressed as a fraction. Now, let's start by doing a recap on dot notation. So 0.3 with a dot on the top of the 3. What does that dot mean? Well, the dot means that this number 3 is going to be recurring. So rather than writing 0.333333, we simply write 0.3 with a dot on the top. So the answer to 0.3 with a dot on top of the 3 is 0.333 recurrent, or this tells us that the 3 is a recurrent number. Now we have a dot above the 3 and a 2. So what does that mean? That means both the 3 and the 2 will be recurrent. So our fraction is going to be 0.3232. Sorry, our decimal is going to be 0.323232 and so on. So just to make note of this, the dot above the number means that the number is recurrent or repeating, as we would say. So here again, both the 3 and the 2 will be recurrent, will be repeating. So our decimal will be 0.323232, and this pattern will go on to infinity. Now we have 0.12 with the dot above the 2. So only the 2 is going to be repeating. So our number is going to be, or our decimal is going to be 0.12222 with the 2 recurring to infinity. And lastly, we have 0.123. Now, you might think, why isn't there a dot on top of the 2? And sometimes, whether you look at British or American textbooks, they might have a dot on the 2. But what this essentially means is that the first all 3 numbers are going to be recurrent. So our pattern is going to be 0.123, 123, 123, 123 to infinity. So as we have here. So don't be put off by the fact that there isn't a dot above the 2. What that means is that the start and the end of the pattern is going to be recurring. So the whole digits, all 3 digits, will be repeating in the decimal. And this is a key skill to understand when we move on to more difficult problems. Now, it says write each recurrent decimal using dot notation. So if you want, you can pause the video and have a go at this, but I'm going to go through the answers. So the first one, 3.333 recurrent. Well, the 3 is recurrent, so we just need to write 3.3 with a dot on top of the 3. And all the answers are there, so I'll go through them and then I will reveal the answers. Here we have 4.5. The 5 is recurrent, so we need to put a dot above the 5. So our answer will be 4.5 with a dot on top of the 5. Lastly, not lastly, we have a 0.29999. So the 9 is recurring, so we need to put a dot above the 9. So our answer is going to be 0.29 with a dot above the 9. With D, 4646464646. So both 4 and 6 are repeating, so we need to put a dot above the 4 and the 6. So our decimal is going to be 0.46 with a dot above 4 and 6. And then lastly here, we have 2.567, 567, 567, 567. So we can write it as 2.567 with a dot above the 5 and above the 7. We don't need to put a dot above the 6. So these are the answers for the first set of questions. You can again pause the video and just absorb what's happened. Over here now, what the question is telling us is that the 7 is going to be recurring. So this can be rewritten as 0.77777 to 6 decimal places. Over here we have 1.67, so our answer is going to be written as 1.6 with the 7 recurring, so it's going to be 1.67777 to 6 decimal places. And now over here we have 0.138, so the 3 and the 8 are going to be recurrent, so our answer is going to be 0.138383838 to 6 decimal places. Here we have 0.56, so similar to the question B, this is going to be 0.5 with the 6 recurring, and over here, all 3 digits are going to be recurring. So our answer is going to be 1.456, 456, 456, and so on. So here are the answers revealed again. So again, pause the video, absorb what's going on, and then you can move on. All right. Now, here's a question for you. So this is where we're going to start converting recurring decimals into fractions. Now, what is 1/3 take away 1/3? Well, hopefully you should be able to tell that 1/3 take away 1/3 is going to be equal to 0. So that is the same as 1/3 as a recurrent decimal is 0.333 to infinity. Now, if we take away 0.333 to infinity from 0.333 from infinity, that should give us 0. So we need to understand this concept really well to be able to move on. So notice that even though we have recurrent decimals, if we take away the same amount of recurrent decimals, we are going to ultimately get 0. So 1/3 take away third is 0, therefore 0.333 recurrent, take away 0.333 recurrent is going to be 0, because as I just said, 0.33 is equal to 1/3, and this is also going to be equal to 1/3, and 1/3 take away 1/3 is equal to 0. So it's really important we understand this. Now, here it says prove that 0.333 recurrent is equal to 1/3. So this is what we're going to focus on for the remainder of the lesson, and this is a grade 6, grade 7 type question in the GCSE paper. Now let x be, so let's say x is equal to 0.3333 recurrent. So I'm going to rewrite this as a recurrent decimal to 4 decimal places. I think 4 decimal places is usually sufficient. Now let's multiply both sides by 10. So what I'll end up with is 10 times x is 10x, and 0.333 times 10 is going to be 3.333 and another 3. All right, because remember, this goes on to infinity. Now notice what's happened here. What we have is the digits after the decimals are now the same. So if I was to take away an infinite amount of threes from an infinite amount of threes, what I'll get is 0. So essentially, by subtracting the top and the bottom from one another, I can get rid of the recurring decimals. So 10x take away x is going to be 9x. And it doesn't really matter which way around you do the subtraction, by the way. You don't have to do x minus 10x. You can just do the larger number take away the smaller number. So the order in which you do the subtraction doesn't really matter, because if you were to get minus 9x, this answer will also be minus 3, and the negatives will cancel out. So I just like to do it this way. Start with a larger number. So 10x take away x is 9x, and then 3.33 recurring. So this is the same as saying 3.3 recurring take away 0.3 recurring, or 3 1/3 take away 1/3. So a third take away third is 0. So what we'll be left with is 3, and likewise here, 3 recurrent take away 3 recurrent is going to leave us with 0. So our answer is going to be 3. So 3.333 recurrent take away 0.333 is going to be 3. Now to solve for x, x is therefore equal to 3/9. 3/9 simplifies to 1/3. So we've just proven that 0.33 recurrent is equal to 1/3, because as we've stated here, x is equal to 0.333 and 0.333 is equal to 1/3. So x is equal to 1/3, and that goes from this statement that we've made here. We said let x be equal to 1/3. We wrote 1/3 as a recurring decimal, And then we found, or we proved, that x will be equal to 1/3. Therefore, 0.3 recurring is equal to 1/3. All right, let's do another example. So it gets a little bit more trickier. It says convert the decimals to fractions. So again, let x be equal to 0.7777. So I'm just going to stop off the 4 decimal places. Now multiply both sides by 10 again, because ultimately you want to get rid of these recurring decimals. The goal is to get rid of the recurring decimals. So x times 10 is 10x, and 0.77 times 10 is going to be 7.7777 to infinity. And now we have the same number of digits after our decimals. So we can now subtract the 2 statements away from each other, the 2 equations away from each other. So what we'll end up with is 10x minus x is going to be 9x. Sorry, I better use a different color pen. So 10x take away x is equal to 9x. And 7.77 recurring take away 0.77 recurring is going to be equal to 7. X is therefore equal to 7/9. Therefore, 0.7 recurring is equal to 7/9. Now I'm going to check my calculator just to see if I've got the right answer. So I'm going to write 7 divided by 9. So 7 divided by 9, if we look here, is going to be, so 7/9, if I press the SD button, is going to give me 0.7777, and then we have an 8 at the end. That's because your calculators tend to round up. But what this actually means is that we have 0.77 recurring. All right, and moving on to the second example. So the second example is slightly trickier. It says, convert 0.12 recurrent to a fraction. So again, let x be equal to 0.1. The 2 is going to be recurring. I've written the 2 4 times again. And now, once again, I'm going to start by multiplying both sides by 10, just so eventually I can get rid of the recurring decimals. So what this will give me is 10x is equal to 1.222 recurring. Now notice I can't subtract the 2 equations away from each other, because if I was to do 1.22222 recurring, if I was to take away these 2 from one another, I should say, the recurrent decimals aren't going to be equal to 0. So think about it as 0.222222 take away 0.122222 is not going to give us 0. So we won't be able to get rid of the recurrent decimals just yet. So if I just delete all of this. So what I will have to do is multiply this equation by 10 again. So 10x times 10 is going to give us 100x, and 1.2222 times 10 is going to give us 12.2222. Now notice what's happened. We have the same digits after the decimal. So now I need to subtract, and I will call this equation A and B from one another. So what I will do is I'll take away 10 from 100x. That's going to leave me 90x. And then 12.2222 take away 1.2222 is going to give us an answer of 11. Notice that these will cancel out, or they will equate to 0. And 12 take away 1 is going to be 11. So now x is equal to 11/90. And again, I can write 0.12 recurring is equal to 11/90. And if I write 11/90 in my calculator, what is my answer going to be? So if we have a look, I have 11/90 If I press the SD button, I'm going to get 0.122222 recurring. So my answer is correct. Now let's do some exam questions. Usually the exam questions are about worth 2 to 3 marks. And now it says prove algebraically that the recurrent decimal 0.47 can be written as 43/90. So again, let x be equal to 0.4777 recurrent. Multiply both sides by 10. Now what we'll get is 10x is equal to 4.777. Again, notice we don't have the same number of digits after the decimals, so I can't subtract the two equations away from one another, so I will have to multiply by 10 again. 10x times 10 is equal to 100x, and 4.77 recurrent times 10 is going to be 47.777. Now notice I have the same number of digits on after the decimal, so I can subtract the two equations from each other. So I'm going to label this one A again, and I'm going to label this one B, so I know which two I'm dealing with. Now if I subtract them from one another, what we'll get is 100 take away 10 is 90x, and 47.77 take away 4.77 recurring, I should say. That will leave us with 43. X is therefore equal to 43/90. And we've proven, therefore we've proven that 0.47 recurrent is equal to 43/90. You could even start by writing let x be equal to 0.47. So we could actually start by beginning our answer like this, and then rewriting the decimal notation as recurrent decimals. All right, and let's do one more example. So it says write 2.742 as a fraction in its simplest form. Now it's slightly trickier because we've got more numbers after the decimal and we've got two recurring decimals. So what we will write is let x be equal to it should be 2, shouldn't it? 2.742, and the dot is above the 4 and the 2. So x is equal to 2.7. Remember, the 4 and the 2 are going to be repeating. So just repeat them twice. You can do it more times if you want. That's absolutely fine. Now I need to multiply both sides by 10. So x times 10 is 10x, and this number multiplied by 10 is going to give us 27.4242. Now again, I can't subtract them from each other just yet, because if I was to subtract the numbers after the decimals, that won't give me 0. So I can't get rid of the recurring decimals just yet. So I'm going to multiply both sides by 10 again. 10 times 10 is 100x, and this number multiplied by 10 is going to be 274.242 4, and I'll just write another 4 here, and maybe I'll write another 4 here and another 4 here. Now I'm having a look again. None of the decimals or none of the digits after the decimal are the same, so I still can't subtract any of the equations from each other. So I have to multiply by 10 again. So what I'll get is 1000x is equal to 2742.424 Now let's see, do we have 4242 recurrent? Actually, yes, we do. Over here, after the decimal our numbers are 42, 42, 42, 42, 42. Here after the decimal, our numbers are going to be 42, 42, 42, 42, and so on. So this equation here, and I will call this equation A. It doesn't matter what you label them. And I will label this as equation B. So these are the two equations you need to subtract from each other. This one and this one, because notice we have the same digits after the decimal. They are recurring. So even if you haven't put, here we don't have that extra 4. Even if you haven't put that extra 4, it doesn't really matter because they are recurrent decimals. So 1000x take away 10x, that's going to give us 990x. So we're doing this equation and this equation, and we're subtracting them from one another. And then 2742 take away 27 is going to be 2715. And then the recurrent decimals will cancel down to 0. So 990x is equal to 2715. X is therefore equal to 2715 over 990. Now, it says as a fraction in its simplest form, we should be able to notice that both numbers end in a 5 and a 0, so they are both multiples of 5. So we can divide both by 5. So I'm just going to rub out what I've done so far, just so I can simplify this. So I'm going to rub out what I've done so far. And then what we'll get is we can divide both by 5. So I'm just going to use the bus stop method. 2715 divided by 5. 5 doesn't go into 2. 5 goes into 27 5 times. Remainder 2. 5 goes into 21 4 times. Remainder 1. 5 goes into 15 3 times. And then we need to divide 990 by 5. 5 goes into 9 once, remainder 4. 5 goes into 49 8 times. And then remainder 90. 5 goes into 90. How many times does 5 go into 90? 5 goes into 90 divided by 10 is 9. Sorry, I've got this completely wrong, haven't I? 5 times 9 I should have written. Whoops, that is really bad. So 5 times 9 is 45. So the remainder is going to be 4. I thought something wasn't right here. 5 goes into 49 9 times. 9 times 5 is 45, so the remainder is 4. And 5 goes into 48 times. So this will simplify to 543 over 198. Now notice one thing, we can use the divisibility test to work out what is a common what we can divide both numbers by. So 543, if we add the digits 5, 4, and 3, what we'll get is 12, and 12 is in the 3 times tables, so this number is divisible by 3. If I was to add 1 and 9, that's 10, plus 8 is 18. 18 is in the 3 times tables, so I can divide both numbers by 3 again. And now I'm just going to use the bus stop method, hopefully without making any mistakes. So what we'll have is 543 divided by 3. 3 goes into 5 once, 3 goes into 24 8 times, and 3 goes into 3 once. So that's going to be 181, and we have 198. 3 goes into 19 6 times, that's remainder 1. 3 goes into 18 6 times again, that's going to be 66. So our answer, we can't simplify this anymore. I can't divide either of them by 5. I can't divide either of them by 2. And if I can't divide them by 2, I certainly can't divide them by 4. I can't divide either of them by 3 either, because 8 plus 1 is 11. 11 is not in the 3 times tables. If I can't divide by 2 and 3, I can't divide by 6. I can't divide either of them by 7. I can't divide either of them by 8. So really, this is our simplest fraction. Therefore, 2.742 recurrent is equal to 181 over 66. And the reason why I did the bust-up division is because usually, or the likelihood is this sort of question would be a non-calculator question. So they might test you on your ability to simplify and divide as well. But if you couldn't simplify it, if you get up to this step here, that's absolutely fine. You will still get probably 2 out of 3 marks. So now if I do 181 divided by 66, my answer is going to be 2.74424242 as I have here. So 181 divided by 66 is 2.7442424242 recurrent. Right, boys and girls, I hope you found this useful, and I wish you all a very nice day. Bye.